image. First things first, I need to get this to not be in perspective. And I have done a great job in forgetting how to do that. Image. Perspective warp. I know. I know Photoshop. Going to be using the outside for the perspective. There we go. There we go. And lastly, that right there. Fudge, I botched it. Try again. Edit. Perspective warp. Okay, is that where we want it to be? There we go. Want that to be right on that corner. That's gonna go down here. And then this wants to go in the bottom corner. Now that that's placed, zoom out, and for warp, that's what it is. There we go. Check. And then we can crop to like there. And save. File. I need to save the image. And then we can go into CAD. I'm going to put it in downloads because I'm lazy. JPEG. And okay, that's Photoshop done. Over to 3D modeling land, where first things first, we drop in our picture. Here we go. Now we need to get measurements. So what we have is we have a ruler that goes to, I see 4.5 inches. Let's just do that. Do 4.5 inches. We need to scale this down. Where's OSnap? We need to make sure we can select the endpoint. We go down to where we think 4.5 inches is on the card, which is about there. And then we set this to, where's the end of that line? There it is. That's not quite right. I think I might have, not what I want to do, undo, so we'll scale from here. Want it to go from here to there. There we go. And now we know that this line here, we've set in the 3D modeling program to be 4.5 inches. And in our image, we go from 0 to, oh wait, no, that was correct before. There we go. The line's 4.5 images, or 4.5 inches in program, which is now lined up with the image. So now we can actually like take the dimensions of this card. The project today is we have these tarot cards of my mother's, and she really wants, she's been trying to make tarot cards herself recently, and she wants a little template that'll help her get this outline for the image. And so that is what we are making. I'm going to place just a filler horizontal line for now. Let's move that down there. We get another horizontal line, just filler for now. We're going to move it about there. And now if we can make a rectangle, we want this to be a 3-point rectangle, and we want the thing to select on intersection so we get the corner. Our height is roughly that, and that is roughly that length. Cool, and now I should be able to just copy these over, and we can start working on the side. Paste. Alright, so now this is the card, both the outer edge of the card and the inner area we want to be able to trace. I think I'm going to do this is I'm going to have the card be able to slide in from the bottom, and then you'll be able to trace 3 of these lines and then place like a plate of some sort over the hole to get the remaining line. Okay, so to do that, first of all, going to make a box. Doesn't need to be too thick. Thinking maybe like 3 millimeters. Need to move to shaded so I can actually see. There we go. Ghosted would probably be better, actually. Shaded is turning the box I made into a solid. Ghosted means I can see through everything. So that'll be the base we're working with. We then want to... I'm actually going to restart that because I want to offset the original curve. Let's offset this. How thick do we want the box itself to be? Maybe like, I think 3 millimeters again. D, we want this to be 3 millimeters. Then we click. Cool. This is the thickness of our box. I'm just going to make all the walls uniformly 3 millimeters. There we go. I should probably move these to separate layers so I can keep track of them. So I'm going to move them to red. There we go. We want it to be able to hold the card. The cards themselves are not very thick. I'm not going to measure how thin they are, but it's slightly thicker than a sheet of paper. So let's see. First thing we want, we're going to want another box. Let's see. Let's do the inside box first. This is going to be the box to like house the card. For height, I'm going to go with 3 millimeters for simplicity. And then we have a second box. Goes from here to here. Again, 3 millimeters. And then we can take this. I think we can scale it up a little larger. And then we can link difference. We want to subtract that from that. And now we have something that the cards can slide into. We want like some sort of lip that holds it down and what is it? Is the size of this box. So I'm going to actually take this back so I can scale it to this size. Let's see. How do I want to handle the like bit that holds the card, the lip? 3D printers can print like a pretty nice overhang. Let's see. I think what I'm going to do is I'm going to make a little curve. So let's get our control point curve. Actually, first I'm going to get a reference for where this line is going to intersect. That's not what I wanted. Try again. There we go. Yeah, that's what I'm looking for. I'm gonna get a control point curve. I want it to go not quite like that. Something along those lines. Actually, a good thing to do might be to grab our midpoint here. Draw that across. There we go. So now if I do a line like that, That's still a pretty sizable gap. I might go even further down then. Alternatively, I could just start from here. In which case, I want the midpoint of this. Grab that, draw it across. There we go. And I am doing this maybe a little lazily. There we go. And then if we trim that, then these we can join. Actually, we can do one better. We can make that, join that curve, and this curve to make a solid curve. We can join and then extrude curve. There we go, and that makes it solid. We can get that on that side. And then we can just mirror it across to the other side. And then the last thing we're going to do is copy this to here. That didn't quite grab from the place I thought it would, so we're going to move up, up. Going to rotate 90 degrees. Going to do a one-dimensional scale operator. And there we go. Now, if we hide that, we should have something that we can both slide the card into, and then also it has enough of a lip along that curve to easily trace that outline. That's the idea, at least. Cool. So let's see. Next thing we need to do, let's actually join these. Also, I guess part of the hope is that the printer's able to handle this curve. It'll handle this easily. Once it gets here, I'm actually not as confident. That's something we'll have to see. Worst case scenario, we can print that with supports and then kind of just carve them back out. So I'm going to take all of our solids one step at a time, just Boolean union them together. There, that's now a solid that can easily be 3D printed. Next thing is we need to have this line, so we're going to show our box again. Scale 1D. Boop, boop. That selected to the center, so we're going to try that again. Scale it down to that inside line, and maybe just a little bit past that. Wait a second, that's still back there. So we need to move it out and then scale it. There we go. I am also going to, let's see, so once you slap that down, you're able to grab that line successfully. There is another line on the cards that are the major arcana. They all have titles, and they have a little box there. So I think I'll basically make two of these. One that's for this bottom line, and then one that's... Actually, I take that back. I have a better idea, which involves... Actually, let's redo these. We're going to copy this, undo back before I Boolean unioned everything. So we can paste this back. Just going to copy this over here. Now we're going to hide this again. Going to rotate this around we want to move it. So this point lines up here. And then from there, we can just do a move back up here. And we're also going to want to cut out a good bit. I think I'm actually going to do something a little strange. I'm going to... not what I want to do. Take this. I'm going to rotate up. Rotate around this way. I'm going to see if I can make it easier to, like, slot the card into. And to that end, I actually want to... fillet edge. Fillet that. We want to, okay, we're gonna need to do radius first. Let's do like a 0.05 inch fillet. We want to fillet that edge and that edge to get to make it easier to get the card into. Yeah, there we go. That's a nice smooth edge. And then we want to... Because I do like the idea of this just being an easy outline right here. And you can just push to make sure the card is in all the way. And then you have a box that you put down in the center if you want the other template. But I think we're actually just going to have to model this in a slightly different way. I'm going to start with a box. Many good things start with boxes. And then I'm going to do this. So this will end up needing support material, but then we can Boolean union. All these, and then we can fillet edge. Just to try to make this whole thing smoother. And then also we want to make sure all these edges here, all these hard edges are nice and smooth. Because it just makes the user experience nicer if you're not touching any hard edges. Have to fillet these bit at a time. I have to go to shaded view to get a better sense of what's going on. That. Fillet this edge as well. So I'm going to undo these last fillets so I can make sure I get all of these as one long edge. Yeah, didn't like that. So let's try that one more time, but this time we just won't go all the way to the edge. Might not look as nice, but... Okay, maybe... Why is it doing that? I guess it's because this edge was already filleted. Okay, so the top might just be a little rough then. That's fine. Alright, so we have these four sides. The next thing we need is like the little interior plate. So I'm going to go to the blue layer for this. I need to make a quick measurement real fast with the card that's right in front of me. I need to see how tall this extra section is. Let's see, is this... centimeters on that side. Does it measure nicely in inches, maybe? It does. It is 3/8 of an inch tall. We can do that. I'm going to make a little line, not from the center. 3/8 inch. So that's how much room we need to like not include in this. Next thing we do, get this. 1, 2, 3. I think I want to go up a little taller than the box itself. That doesn't look right. What I can always do is just give it a little shrink, because when you 3D print things, dimensions aren't always perfect. So it's also just nice to have some wiggle room. And also, I mean, there's the thickness of a pen or a pencil. So I'm gonna shrink this down maybe a little bit more, just a tiny bit. There we go. Nope. There we go. All right. Now we actually do want the little center function. I want to make a nice little like handle on this that you can easily pull it up and push it down with. Okay, point. There's O-snap is on center. Oh, it was there for a little bit. There we go. Okay, there we go. We can use this to make a line. I want this to be a nice vertical line, because what I'm going to do, I'm just going to kind of wing it. I'm going to try that one again. Okay, then we're going to have a circle. Let's say maybe that large. And then what I'm doing is I'm basically designing the handle in profile right now. So this would be what it would look like from the side if cut in half. Control point curve. There we go. We're going to use this to actually, we don't want it to go all the way. We still want some width. There we go. That much. 1, 2. Make sure we smart track to that. There we go. Use these to trim. Then what we can do is we join all of these back in perspective view. We get this. We're going to revolve around this axis. And there we go. We get a little bit of a derpy looking handle. And then we move it here. And then we'll just slide it back up. There we go. And then we take this and I'm going to fill at the edges, because that's just nice. Actually, I'm just gonna fill at the top edge. I'm going to keep the side edges hard so that they have nice contact with the box. There we go. And then we can Boolean these together. So that's a solid. this is a solid. And so what we do is I'm going to save this real quick, and then we're going to go over to the 3D printing phase. Let's see, let's call this Project Tarot Outline. How long has this taken? 25 minutes? Oh, we're making great time. All right, so now we have two parts we want to 3D print. We have this blue inside part, and then the outside box. So what I'm going to do is I'm going to do these one at a time. File. We're going to export selected. And for our file type, we're going to do STL. I know you can't see this because it's on my other monitor, but I'll try to keep this fast. STL stands for stereolithography file. It's a way to encode 3D data. We're going to save. Oh, before we do this, actually, one big thing we want to change. Units. Right now, this file is in inches. We want to change it to millimeters because any manufacturing program worth its salt works in millimeters. There we go. And now the units are in millimeters. When we export it, it'll try to read those units as millimeters because units themselves aren't saved. It's just the value of them. So if this is like 25 millimeters, if this was in inches, it might read, I don't know what 25 millimeters is in inches, like 8, we'll say. It's probably wrong. But it'll say like 8 units, and when we go to the 3D print program, it'll read those 8 units as millimeters, so it'll be really small, and you'll need to multiply it by 25.4. But if we just export it as millimeters, then everything works out fine. Okay, cool. File, export selected. So this first thing, we'll call it, first of all, STL, and we'll call it like Tarot Knob. That doesn't seem like a bad wording. Save that. We're going to encode it in, there's a few export options here. There's either binary or ASCII. We're going to use binary because it's smaller. I don't know why you'd use ASCII, honestly. And then file export selected. I'll call this Tarot Box. We'll do template. I think somewhere else on my computer I already have one called Tarot Box. And once again, I'm going to do this in binary. Ooh, okay. I just saw an interesting pop-up. So what we're going to do, I'm going to do the show edges command. So we can see on this top piece, we have 22 edges total, no naked edges, no non-manifold edges. That's what we want. And now what we do is we're going to remove objects. We're going to add objects, and we can see 12 naked edges. Where are those naked edges? Okay. Why are those marked as naked edges? That means somewhere in Rhino. Yep, there it is. There's no actual surface there, is there? Okay, well, in that case, what we're going to do... that's a hard fix. See if I can rebuild these edges, basically. Do this. We want distance. I just want the length of this side here, 1.27. So we're going to fill it edge. We want the radius to be 1.27. We're going to fill it this edge. To fill it surface. Not what I was going for. Undo, please. here's another idea. What we can do is grab our circle. Just double checking that, yep, that is indeed a circle. We're going to take this, we're going to extrude it. We're going to subtract our new cylinder from this. I did it the wrong way. We're going to subtract from this, taking out that. So now we have this solid, which I'm going to mirror over. And then, actually, I'm going to undo that because we want to scale 2D. I'm going to actually scale it up and then mirror so we make sure that we cover the bad area. Then if we join these, still got those naked edges. I wonder if I'm gonna check something because I think it doesn't matter for this case because that area is still solid. The 3D printer should read that as an error, but it shouldn't change anything. Terra template. Admittedly, that is one of the small gripes I have with this program. Is sometimes when you think things line up, they don't. Gonna export that. All right. Next, we go to Slicer for Prusa. This is a slicer. It takes 3D models inputted in STL format, and it turns them into gcode, which is the code needed for a 3D printer to actually like 3D print, because 3D printers, they need tool paths. They don't care about the 3D model. They just want things to go from point A to point B. And okay, so you can already see that the 3D print software was more than happy taking this as an input. Just checking, because that doesn't look right. Did I forget? Yeah, I think I forgot to add back this final box area in the back. So I'm gonna go back to Rhino, I'm gonna double check. Yep, that's its own object. I'm gonna Boolean union that. That did something. Boolean difference. Gonna subtract from this, subtract with that. Did it work? No, it did not. There's always another option, and that's called doing things in a slightly lazy way. Just like before, where we had a box. 1, 2. Just gonna 3, and last point goes there, 4. That out of the way. Man, it really doesn't like Boolean unioning this. And I bet it's because of these non-manifold surfaces, it's having trouble reading what's supposed to be inside the shape and what's not. Which is very strange. Rhino, you usually do a better job than this. Not gonna lie, I'm a little sad. But okay, we're gonna move that a bit. We're just gonna try this again. Okay, so on the off chance that is not working. Oh, Lord. I'm gonna explode this. What we're gonna do is we're going to explode this so the whole shape is nothing but a bunch of empty surfaces, and we're going to patch up this hole manually. Let's see here. How do we want to do this? Where's the vertical plane? 1, 2, 3. 2, 3. 1, 2, 3. 1, 2, 3. And now I'm going to also clear away some of these other lines that I don't want in here. So we only want surfaces. Actually, what I can do is just cell surf. Join. Get rid of these. There we go. Join. Show edges. 122 edges total. No naked edges. No non-manifold edges. Cool. Wait a second. Oh, that's wacky. So these poly surfaces here joined well. That's real wacky. Hide that again, and this. Okay, guess we're just gonna build our little box again. That works fine for me. Do this as a 3-point box. There we go. Don't want to go to center. Want to go to there. Boolean union. Okay, that's good. So now should be able to join these back as well. Boolean union. Okay. Show just one last time just to confirm that there's no weird edges. And cool. File. Export selected. Terra template. Gonna replace it. And there we go. Now we go back to this program. Good thing I noticed that. Gonna delete that. Put this in. And okay. Final steps we need to do. We're going to prep the parts for 3D printing. So print settings, infill, 30% is way higher than we need for this. We're gonna do 20. Hilbert Curve's been working recently on this 3D printer, so we're gonna do that. Fill pattern honeycomb is more than we need. We're just gonna do grid. Cool. Then layers, layer height. We're gonna do 0.3. This is not like a super precision piece. You know, we'll do 0.25. That's at least a little cleaner, and it's a nice number. Perimeters 3, solid layers. Cool. And now, if we slice, we can go to preview. Did Hilbert infill? We want top bottom pattern to not be Hilbert. We want Archimedean chords is what I like. Slice again. Ooh, printer's taking, or the slicer's taking a while. Okay, preview. And there we are. So we can see that's now all the layers needed for this 3D print. Okay, technically I think it still needs supports. So we'll have it auto-generate supports. Yeah, because that overhang's too high, or too steep, and that's also just like a flat line. So print settings, we want support material, generate support material, yes. Okay, one more time. Slice. And there we go. Now there's a lot of very tricky to remove support material. What did it decide to do down here? Yep, that's going to be a real pain to remove. But it'll work. And just like that, in 40 minutes and 55 seconds, we created something from an image to literally ready to put on the 3D printer. That's all I had to stream today. Thank you. Thanks for stopping by. Hope you don't mind the short stream. Yeah, that's kind of it. Hopefully this was maybe a little insightful to the process I go through when I want to 3D model and 3D print something. It really doesn't... I could have done this without really cutting-edge 3D modeling software. There's definitely things like Tinkercad where you can basically do this whole process online for free. So it's pretty nifty. But yeah, no, that's it. Hope you have a great day as always, and hopefully I'll see you next time. Peace.